Hey, welcome to the channel. This is a webinar that I did recently, and I had a lot of traction from it. A lot of people were asking to see it or see it again, see where they could rewatch it and that sort of thing. I wanted to run through this for you, for anybody who was not able to see this. Hopefully it adds some kind of context of workflows, how you can utilize various software applications to achieve your hydraulic modeling processes for your projects. So let's go ahead and run through this. So first of all, kind of looking at our agenda, I'm going to give you kind of a quick overview of, basically what I'm going to cover. What we're going to do then is we're going to go into some development and analysis, how to create your initial models, your initial projects. Once that's done, how to ultimately refine that and go into detailed engineering design for that. Once we've done that, we're going to move into looking at sizing and performance of the network that we've developed, and then integrating it into larger scale systems. And then finally, circling back to your detailed design documents to update them based upon what we found from our analysis. So, quick overview. I'm going to use a series of different Autodesk applications for this. And so I'll go into each one of them, kind of explain, what the benefits are, what they do, if you're not that familiar with them. But we're going to start off on InfoWorks. That's going to be kind of our launching point where we first create our content, build out the initial model. From there, we're going to move into Civil 3D, ultimately taking that initial model that we built and streamlining that into at least the base design for our construction documents. From there, we're going to move into analyzing it. And for that, we're going to use InfoDrainage. And InfoDrainage is going to help us to size it and check performance, that sort of thing. And then ultimately, InfoWorksICM, which is going to help us to determine whether the design that we're doing for our project is going to impact the larger system, whether it be the city, county, municipality, whatever it may be. So, and then fully round robin everything back into Civil 3D once we're done and we're happy with the results to finalize our documentation. So it's going to be a full life cycle starting from nothing to ultimately getting a detailed design done in the end. So quick example, but hopefully this will be informational to you. So starting off with InfoWorks. So if you're not familiar with InfoWorks, again, it's Autodesk's kind of initial planning as well as presentation tool, but it's evolved over time. It's done quite a bit in adding a lot of new tools to it and a lot of functionality, including a lot of pipe networks and hydrology tools. There's quite a few other things too, but that's kind of where we'll be focusing today. But as you can see from what I've got listed here, it does a lot of these things here, generating those existing condition models, rainfall data, watersheds, drainage networks, all kinds of fun stuff. So let's go ahead and get started in that. So to start off with, I'm just going to launch, in my case, Google Maps, but any map service you want. Search for your project. Once you do, right click and then just capture the coordinates for it. From there, we can go into InfoWorks and then launch what we call the model builder. And then from here, all we need to do is paste in those coordinates that we got from our mapping service. It's ultimately going to take us right to where our project is located at. And then this is where we can go ahead and define the extents of our project. So I'm just going to drag out a window so you can kind of see where that's going to be located. I'm going to give my model a name so that I can identify it later on. And you have an option to put a description on as well. Right here is where we want to put in our coordinate system. This is very important. You want to make sure you do this right here because once you create the model, you cannot change the coordinate system. So in order to save a little bit of time, I've already created one. So same exact steps, same exact location. And you can see this is what the model builder created for me. So it went out to several online servers and was able to pull surface data, road information, whatever it could find. And capture all of that and build me a 3D model for this. So this is already, a huge step starting from absolutely nothing other than knowing where my project was located at. And so great start. So what we're going to do now is we're going to go ahead and analyze the watershed areas. So for this demo, just going to pick a small piece of one road, so, just kind of keep it small scale for kind of what we're looking at. So I'm just going to take a look at what impacts those watershed areas might be in this location on this segment of roadway. So it just goes through and it starts analyzing and determining, what the impacts are going to be. And then it starts generating those watersheds for me. And so you can see it's already done. And this is all real time. I didn't speed any of this up. And so you can see that watershed has now been defined right there. And we can easily see that it's coming down and ultimately draining right into where that road is. So you can see I've placed a little flag there so you can kind of keep an eye on where that location is going to be of interest for us. So already great. We're already getting great information. We haven't done or modeled anything, personally. And now to add a culvert crossing, literally all you do is right click on it and say, add a culvert. And you don't pick the start point, the end point, put in elevations or anything like that. You literally just say, put in a culvert. It looks for the low point. It looks for that streamline that you can kind of see ghosted in there. And it places that culvert there for us, which is great. So already done. Again, doing the work for us. We're just using the tools that are available. We're not having to go through and analyze or create or define anything up front. We can go ahead and select that watershed, and in here, we can set some of the properties in it. For example, like the hydrology method that we're going to use for this. And once that's been selected, you can put in things like runoff coefficients, rainfall intensities, whatever it may be that's related to that catchment. So just go ahead and populate a little bit of information here. And that's all you need to do. Good and done. Now that we've done that, we can take a look at that culvert that it created for us, because this gives us a lot of options with this culvert as well. So I can go ahead and select that. And you can see, again, the properties panel is going to populate just a moment. Again, all of this is real time, so you're seeing the actual performance of it. And you can see all of the metadata that's already associated with this. And you can make changes to it. So you can see, for example, the pipe, the size, right now it's a circular pipe. We can switch it to a box culvert if we want to. It's going to regenerate that. And in the graphics, you'll see update right here in just a moment. So now we have a box culvert. We can continue to go back into here and make other adjustments. Maybe we want additional barrels in here, so we can put that in as well, which is great. We'll let that update. Give that a second. It starts regenerating that culvert. And there we go. Now we have double box culvert in there also, which is really cool. Again, you can see there's lots of other information that you can put in here. What are your inlet configurations going to be? Are they going to be tweaked or adjusted in any way? There's lots of other properties and information that you can adjust or manipulate from that properties panel as well. And so you can work on the inlet, the outlet, the pipe itself, whatever it may be. I'll kick this back down to a single barrel, and that looks good. But you can see how we can set up tailwater, end treatment conditions, performance, lots of things like that. And then there's even a report tool over there too. So we can quickly run a quick report on what that pipe is doing, what its performance is going to look like, which is cool. From here, now we're ready to start refining that design. So for that, we're going to utilize Autodesk Civil 3D. And in Civil 3D, again, if you're not that familiar with it, kind of a universal, all-in-one encapsulating civil design package. So it does a lot of great things for design, analysis, construction document generation, all that fun stuff. But yeah, I can do everything from survey, surfaces, drainage, again, catchments, all that fun stuff. So lots of great things we can do inside there. So jumping into Civil 3D, you'll see that what's really nice about this is we didn't have to export or anything in InfoWorks. The two products are actually integrated, and we can open the InfoWorks model directly from inside of here, which is really nice. So I can just go ahead and select that. We didn't have to export or import or anything like that. Once we define it here, we'll go ahead and choose our coordinate system, and we can tell it to use whatever we defined in InfoWorks, which is great. There's a lot of other options in here also. You can choose how much of the model you want to bring in, which features of the model you want to bring in case you want to reduce the project size or anything else, but it's going to go ahead and process everything that it finds by default or based upon your settings. So it looks like it's bringing in about 350 items in here. And so you can see we got a lot of data that came in. We got all the road alignments, surfaces. I went through and just kind of did a quick cleanup on some of the styles, so it's a little more visually appealing. So I'll jump to a copy of that one, just again, kind of streamlining things. But you can see we got all of our alignments, we got our surfaces. When we used component roads, we actually got corridor models. We got the catchment areas. When we turn on the geolocation, you can see the coordinate system is maintained. It's falling right on top of the aerial imagery, which is really nice as well. So we can see that's all in there. That all came across. And then we can also see there's the pipe. There's our crossing. So again, very quickly, just utilizing some of the tools that are available, we're able to get all this stuff without really doing a whole lot. Taking this into our 3D object viewer, I selected the corridor model of the road itself as well as the crossing, and we can see the definition of that inside there. So we even have 3D model data already, which is really nice. If we go ahead and select that pipe and start looking at the pipe properties, you'll see that it did capture a lot of that information from InfoWorks. So we have the pipe slopes, the inverts, coordinates, things like that. But you'll notice the hydraulic properties are all empty. So no values have been set at this time. So that's what we need to really start looking at and focusing on next. So that's going to be our next step. We want to start analyzing, how's the performance of that pipe? How's it going to work for us? So in order to do that, what we need to do is start incorporating InfoDrainage. And so Autodesk does give you a free install that you can get that will give you a custom InfoDrainage ribbon that you can put on top. And this will connect those two applications together. So very easy to define that and spit that out so it goes over to InfoDrainage for us. So from here, we can choose which networks we want to bring in, as well as do we want the existing ground to come with it. Then we go into a parts mapping dialog through the wizard, where we're just going and defining. You can see we left it off as a box culvert, 24-inch. Again, we just went with the default values that were captured from the initial design through InfoWorks, but it found it. So the data is there. So everything looks good. So we'll go ahead and say finish. It captures all of that information, and we're good to go. So next we'll start looking at, again, sizing and performance. So for that, we're going to jump to InfoDrainage. I know we're going all over the place, but again, I'm showing you how all these tools can connect together to work hand in hand to kind of get you to the results you're looking for your project. So InfoDrainage, if you're not that familiar with it, it is the latest and greatest Autodesk drainage analysis tool that is available. A lot of the previous tools have been kind of shelved, so to speak, or kind of put on the back burner, and they've stopped the development and evolution of those tools. So InfoDrainage, again, does a lot of great things. You can see a list of all the different tools and features that are available within it. And you can think of InfoDrainage as a project-wide, project site analysis tool. Really great for, working on your project, running the analysis. So jumping into InfoDrainage, we'll go ahead and select the file that we just created. You'll see that it brings it in. And initially, we just have that the pipe network that is in there. You can see that right there. There's our crossing. It did bring in the surface as well because we told it to, so it was just turned off. So over on the tool panel on the left, the tree view, you can see how we can enable that. And then again, if we start looking at the properties of that pipe, we can see, once again, it's that 24-inch box culvert. Again, just the default values that came across initially. We haven't done any sizing or performance on it whatsoever. Another thing we can do if we wanted to is we can also start bringing in that catchment information. So we'll go ahead and bring in some CAD data as an inflow. We'll go ahead and choose that drawing that it was initially created in. And then from here, it's really just choosing a layer. And so we'll let that generate for a second. And anybody who's used Civil 3D knows that Civil 3D has a ton of layers. Unless you really slim down your template, there's just going to be a lot of layers. So we'll just go ahead and turn them all off and then scroll over to find the water catchment layer, which is where that watershed boundary was placed on. We'll enable just that one layer. And it's going to come in as a catchment. So that all looks good. We'll go ahead and say finish. And then you just get a summary that was brought in. You can see now that we have that catchment, which is really nice. And it's defined it as a catchment object. So you can see the little icon, the imagery there, as well as the properties that have been defined in it also. So lots of good stuff. Again, very streamlined in the way we're doing the workflow on here, which is really nice. And so once you have all of this data in here, you can utilize the InfoDrainage tools to start analyzing, what the performance of this is going to be, get it to size it for us, so that we can ultimately round robin it back in. So you can come over into your rainfall pollutants ribbon, go over to your rainfall manager. You'll see that it comes with a handful of design storms, but you can create your own and customize them as well. We get into some preliminary sizing. We can look at the network design wizard, see that it's got that in there so we can size that as well. Also coming in, looking at the design criteria manager, setting up our parameters for how we want it analyzed. And then ultimately coming into the analysis ribbon, running the analysis. And then from here, we'll be able to come through and then look at the performance of that. So we'll launch the profile flow path. And now we can see it's been adjusted. If you look at the details down below, you can see it's now kicked it back down to a 12-inch, and that's going to be a good parameter for us. If we start scrubbing the timeline down below, you can let it play or you can adjust the speed on it, but just kind of doing that. You can look, it's very slight, but if you're looking in the profile view, you can see that water performance kind of going up and down inside the pipe. So we know that everything's working. We're just looking for things that are going to be surcharging, things that are going to be causing problems, stuff to watch out for. It looks like everything seemed like it ran pretty well. So I think we're in good shape. So the next thing we want to do is now we know it works for our pipe. We know it works for our project. But again, how does it work downstream? How does it work in the big picture? As we're tying into the system of the city or the municipality, are we going to cause any problems downstream? And so for that, we're going to start looking at how it's going to integrate with everything else. So from here, we're going to start utilizing InfoWorksICM. And there's a lot of, overlap and kind of crossover between InfoDrainage and InfoWorksICM. Again, as I mentioned before, I think of InfoDrainage as more of a project level analysis, where InfoWorksICM is more big picture. So again, not only am I analyzing just the specific pipe or the specific project area I'm working in, I'm actually going to compare it against GIS data, whatever information I happen to have for the overall network. And so again, it's going to do large scale systems. It does storm as well as sanitary, a lot of the overlapping, again, catchment modeling, design integration, performance analysis, stuff like that. So we'll jump into here. You can see it already started off by bringing in some of the GIS data. So I have some of the existing storm systems for this area. And you'll notice if I come over to import, it has a direct link right to InfoDrainage. So I'm able to grab that file, pull that right in. I just get a quick log result of, what I brought in. You jump over to the network view and you can see how it brought in the catchments and everything now. So that's all in there. That looks good. Our pipe crossing is in there also. That looks good. So again, now we've got a big picture of how things are operating. And now we can run performance on this one as well. And now we can look at the top view, which is our network view, which is kind of our flood areas. And then down below, kind of a blown up view of what we were looking at before in InfoDrainage. But again, we're looking at the network performance of this pipe. And we're looking again for things like surcharges. Are there going to be any problems? If so, in the top view, in the network view, it'll start highlighting system elements, different assets in red, saying, hey, you might want to look at this one. It might cause a problem in this one area. So those are the things we want to look for. And if we don't see any, then we know we're in good shape. Again, we're not seeing anything surcharging too bad. The pipe water performance levels are looking good. I think we're in good shape. So good deal. It's a good safety checker. You don't want to have to get flagged by the city after you submit your design, saying that you're going to have to improve something downstream. So that looks good. And so now that we're confident in our design, we can go back and start updating our Civil 3D design and ultimately generate a construction document for this. So again, utilizing our InfoDrainage custom ribbon, that again, it's free. Just go ahead and install it. We'll go ahead and import the InfoDrainage data. And again, we'll go ahead and select that same file that we were in. And we can see here, we can choose whether we want, which network we want to bring in. Do we want to bring in any surfaces or use the ones we've already got? All that fun stuff. We can see what it's planning on bringing in. We can see that pipe is there. And so, yep, it's now at a 12-inch. That's exactly what we were looking for. So everything's good. I'm liking that. We'll go ahead and say finish. It now updated that system because we didn't tell it to bring in as a new system. It updated the one we had. And you can even tell with the label there, the pipe label, it says now it's a 12-inch. And if we go ahead and generate a quick profile of this pipe system, we'll just zoom on out and find an open space where we can drop this down. You'll see that it quickly generates that, but you'll notice the magenta and the green lines. That's your HGL and your EGL. They've been calculated through InfoDrainage, and setting up your profile style to enable the display of the HGL and EGL. It's going to put those on there as well. And then if we look at the pipe properties, you'll notice now all the hydraulic data is now associated to that pipe. So everything looks really good. So I'm liking that. And take a look at the catchment. Again, we can see the property information here on the properties panel. Looks like it retained all that information as well. So we have our runoff coefficients, we have our acreages, everything looks good. I like it. And then so ultimately, once that's done, we can go ahead and generate that, again, construction document. So generate a plan and profile, or kind of section in this case, where we're showing those, dimensioning those, annotating, labeling, HGL, EGL, stuff like that. So lots of cool stuff that is in there. So I know that was relatively quickly. I didn't go click by click. This is how you do this step 1, 2, and 3. But I did want to kind of show you, how you can start with nothing other than just a location for a project, and then utilize some of these tools to automatically generate a 3D model, automatically send it to Civil 3D, automatically size it, automatically check the performance against the bigger picture network that you'll be tying into ultimately, and then how to round robin that full circle back to Civil 3D to update your plans and make sure that everything is working, sized right, and going to be constructible without any issues. So hopefully that was helpful and instructive. Again, if you have any questions, comments, leave some feedback down below. But other than that, thanks for checking it out.